Last class I mentioned, we're going to start next time by formally defining this. And like the lion bastard that I am, we just kept going without defining it. So let's define what makes a binomial, and then I've got a whole bunch of cases of experimental trials, and you can decide which ones are and aren't binomial. So that's the idea. Now that you know what it is, it's great, but now you're going to want to see it everywhere. But it isn't everywhere. But where it is, you can get it. So the first thing is, you have to have a fixed number of trials, and this word is so important, but it's glossed over often. Independent. The trials cannot affect each other. And then in the italics under that I put, for this exercise, it's the 4 chicks, which are arguably independent. This was the trick. Because there were so many birds in the store, and we were only pulling a small number, the probability of 90% wasn't being altered as we removed birds from the bin. If there were only 4 birds in the bin, and Max is pulling all 4 birds out, that 90% is not going to last very long, if you think about it. It's going to go down, it's like actually you can't 90% with 4 birds, regardless. But the thing is, arguably independent. Carly, you asked me what arguably was last time, if I remember correctly. How big a sample or can you draw from a population until it's not independent anymore? Great question. Guideline to work off of, make sure your sample isn't any bigger than 5% of your population, or your perceived population. Sometimes you don't know what your population is or how big it is. So make sure it's no bigger than 5%. And honestly, guys, you're not drawing anywhere near 5% of most populations. If you're doing studies on ADHD children, you're not pulling 5% of them. You're pulling 0.005% of them or something tiny like that. Go ahead.
So anything without replacement couldn't be a binomial?
Technically speaking, no. Without replacement, technically you can't use the binomial.
Because they're dependent.
Because they're dependent. What happens on the first trial governs what can happen on the second. If you can view your experiment as rolling dice, technically that's with independent. A die roll doesn't know what happens before or after. It just knows what it does. So yeah, anything with replacement back in, yes. Anything without replacement, technically not. But realize that we can caress that if you can make it arguably independent because you're drawing such a small number. Is that fair? That's why we treated Max as independent and not dependent, because we could. Fair enough? Okay. Now, Pat, you asked the parameters. You know, you have to know that probability, and in order for it to be binomial, that has to be applied to this. 2, that's what makes it binomial. Very nice. 2 mutually exclusive outcomes. 2 mutually exclusive outcomes. If I have time over the next week, the final class, I have the trinomial distribution put together for you guys of the 1 in 10,000 bird that has both genders. Remember I mentioned that? I actually have the distribution for you. I'm going to slap that out as a quiz and say, find the average of this. How different is it from the one we calculated? Because that's fun. I mean, that's worth, I mean, I sent a response back to that student. I said, you're right, here's the distribution. Never heard back, kind of bummed about that. But
so it's the chick that's being male and female, that's the 2.
That's the 2.
Just like when we do, like when you did like the colors thing, like it's either a green block or a blue block.
Yes, that was binomial as well.
Right.
The trick with that one was, since we were pulling the blocks out and not putting them back, and there were only 10 blocks, that technically wasn't binomial, it was called hypergeometric. It satisfies everything for the binomial except for that. And think about why. Think about why. In that bag, did I tell you how many blocks were in the bag completely?
10.
10 total. I think it was 7 blue and 3 green.
Something like that. Yeah.
7 blue, 3 green, I think that was what it was. So right, when you start pulling, the bag is 70% blue. Right?
Right.
That makes sense. And then you pull the first one out. It's not 70% blue anymore. It's now 6 out of 9, right? 2/3, which is 67%. That just dropped 3% by removing a block. These weren't moving anywhere near that by pulling a chick out of 500. See, that's the kicker. That's the kicker. You removed 10% of the population when you pulled the block out. Does that make sense?
Yeah, no, it does.
That's the kicker. Hypergeometric, which is what that distribution is called. I wish we had more time to talk about it. We don't. But hypergeometric is everything a binomial is except for that. And it's useful. That's what Powerball uses. Almost all lottery games. The extra credit for that one quiz, which is still out there if you guys want to go for it. The pick 4, pick 5, whatever that was, that New York game you guys analyzed in class a couple days ago, that was hypergeometric. So it's cool. It's really cool. It's just that binomials are more overreaching. Go ahead, Carl. Question.
Well, I just was gonna say not only is it dependent on the fact that you took one block out and there are fewer blocks, but it depends on what the color
What
of the
color block
is.
you got. Whereas removing the chick, if it gets to be a rooster or a hen, it doesn't matter, it's still 90-10. But if you pull the green block out first, now it's actually higher percentage of blue than it was before, yeah? Because you remove some of the less blue. Yeah, that's the problem with the hypergeometric versus the binomial. And people get in trouble sometimes in research even, mixing them up. That's why I have the next little bit through where we actually go through and so we see different examples of experiments and you pick which ones are which. We'll get to that, I promise. And third, assuming that you can break it down to two mutually exclusive outcomes, you gotta make sure, and this is pretty much what you were talking about, Pat, you have to make sure those probabilities stay constant. And Carly was just mentioning this too. Those probabilities cannot vary. So for us, females 90%, male 10%, boom, that's it. That's it. They don't vary. Because you're pulling these chicks from these large bins. I'm interested by the time we finally get to the store to buy our chicks if it's going to be hypergeometric or binomial. Depends how many birds are left in the store, right? I mean, there might be like 10 birds left in the store. I'm like, well, Max, go pull 4 of them. Let's hope they're not roosters. But then it becomes hypergeometric and not binomial, and it becomes more interesting. Cool? This word hypergeometric, if it's freaking you out, this word hypergeometric, you can just flush it away. You don't need to know it for this class. It's a wonderful distribution, it is. It is wonderful, but it also is very specific to certain applications. Vastly more prevalent is this guy, which is why I've chosen to work on him. I'd rather spend, if I have a week to spend on distributions, I'd rather spend 1 week on this rather than say 1/10 of a week on each of 10. There's the geometric, which you'll see on the quiz for next week with the Gambler's Ruin. That's the geometric, and it's wonderful. If you want to do it, do the quiz. That's great. There's the hypergeometric. There's the Poisson, which is the one insurance companies use to model how much we should pay somebody when they fall in the shower and split their head open. It's a great distribution. It's fun for that reason alone. But again, it's that reason and that reason alone. Like, it's important for somebody, but not for most people. That makes sense? Yeah. Cool. All right. Now, I gave you the program. That's my reminder to give you the program if I haven't already done so. But we have. We can skip over that part. This is Mike. Mike Smith. You might know Mike. He works at the Cap Center at the library. He complained to me a few years ago-ish. I think it was a few years ago. He bought 7 chickens, 7 birds, 7 pullets, and got a rooster. He was complaining, but he actually heard me giving this talk with students in the basement of the library. He's like, yeah, this is crap. I bought 7 birds and got a rooster. And he was pissed about it. And I was like, Mike, you have no right to be pissed. And Veronica is going to prove why Mike has no right to be pissed. Because what is the likelihood? What is the likelihood of exactly that happening? You can now answer that question, can't you? You can answer that question, can't you? What is the likelihood if you buy 7 birds? If you buy 7 birds from High Desert Ranch and Home or whoever else has